Welcome to this week 7 question number 3 tutorial, and let's go straight into it. And the problem reads that an investment website can tell what devices are used to access a site. The site manager wonder whether they should enhance the facilities for trading via smartphone. So they want to estimate the proportion of users who access the site that way, even if they use their computer sometimes. They draw a random sample of 250 investors from their customers. Suppose that the true proportion of smartphone users is 26. That's the information we're given, and we're asked a couple of things. First part, what would the standard deviation of the sample of the proportion of smartphone users be? And this is a recap from the textbook. It gives you a couple of symbols that we're going to use. We're going to use P as the proportion for the population and P hat as the observed proportion of the sample. Now, Q we're also going to use, which is the proportion of failure, and that's going to be 1 minus P, which is the successes. So these notations are important, and the formula for calculating standard deviation for P hat is P times 1 minus P over N, or P times Q over N, and all of that. You find the square root of it. So if we were to do that, which is what is asked in part A, the standard deviation, N is 250, P is 0.26, and this is given in the problem as the true proportion of smartphone users. To calculate Q is 1 minus the value of P, which is there, and if you look at the formula here, you can see how we got to it, and that's coming from the notes. The standard deviation from this formula here, that's what we have calculated here, the value of P times Q divided by N, and all of that, we're using this, which is the key above the number 6, called the caret. That raises anything to a power, and to find the square root, we raise it to the power 0.5. So that's how this whole expression becomes a calculation that is given here. Alright, so take a look at it and see. We certainly want to reduce this to the correct number of decimal places, which I think we're asked to do. I want to say it's 4. Alright, so that's what the answer would look like. Moving on to part B. What's the probability that the sample proportion of smartphone users is greater than 0.26? Now, if you recall what the 0.26 means, that's given to us as the mean. This implies that there is an equal chance that the sample probability of smartphone users will be greater than or less than 0.6. So the probability that is greater than 0.6 is going to be equal to 0.5 and not 0.6 as I've written there. I'm sorry. So probability of being greater than 0.26 is going to be 0.5 because 0.26 is the mean. Part C, what is the probability that the sample proportion is between 0.19 and 0.31? Now, in order to do this, let me rush to this graph here. If we can find the probability, or let's put it this way, we are interested in the shaded area, which is the probability that it is between 0.19 and 0.31. Now, I can show you how to find the probability that is less than any value. If I can find the probability that is less than 0.31 and then less than 0.19, I can then subtract those two to give you this common area. So let's go ahead and I'm going to show you how to do that. So let's find the probability that the sample proportion is less than 0.19. 0.19 is our reference value, and we can calculate the z-score from this expression here, p hat minus p over the standard deviation of p hat, and that's what this formula does. And if you notice, I've referenced B34 and B36, which are my standard deviation previously calculated and my value of p, which are both in this formula. So I'm just building on what I have done before instead of repeating calculation. So this is my z-score, and in order to calculate the cumulative probability, because what I just did, I found the z-score equivalent to this 0.19. So what I'm saying, in the z world, this is minus 2.523, if I could call this z-score. Right, and what that means, I can then use the norms, this function, which returns the standard normal cumulative distribution for a distribution that has a mean of 0 and a standard deviation of 1. For it to be like that, I have to use the z-score. That's what the power of the z-score is all about. The z-score, the mean is always 0, and the standard deviation is 1. It's a standardized way of expressing scores or proportions in this case. So from that, that's what I use here. I use the norms, this function, input B55, which is the z-score equivalent, and what I'm getting is that 0.005813 is the cumulative area up to this point. So that would be all of here, the area that is white. Now for 0.31, similarly, I calculated my z-score using this same formula here, and then I calculate my cumulative frequency or my cumulative area, which is using the norm this function. So this pink area is 0.965, which is what I got here. Now, in order to calculate the probability that is between 0.31 and 0.19, I would have to subtract this area from this area. So effectively what I'm doing is subtracting this area in white here from the overall area, and then what I will be left with is this area right here, which is going to be the probability that is between 0.19 and 0.31, and that's your answer right there. And again, we can go ahead and reduce this to the number of decimal places that we are being asked for, and I think we're being asked for 3. Alright, so 0.958 is going to be that response. And again, the z-score equivalent for the 0.31, since we have it just for completion, let me stick it in here. Okay, so that's how you would find the probability that the value is between 0.19 and 0.31. Now moving on to part D, what is the probability that the sample proportion is less than 0.17? Again, the reference is 0.17, the z-score I can calculate from this formula here, right? And then the cumulative area, I am using the norms dist function, and I am getting that for 0.17, the z-score is minus 3.24, and the cumulative probability, get that down to 4 decimal places, is going to be 0.006. 0.0006, I'm sorry. So therefore, what we're saying here, and if we wanted to take that down to 3 decimal places, as we were asked to do, the area below 0.17 is 0.001. So what we have done again, just to re-emphasize, we translate 0.17 to a z-score in order to be able to use the norms, this function, to translate that z-score into a cumulative area, and then that gives you the probability that the score is less than the sample proportion is less than 0.17. What is the probability that the sample proportion is greater than 0.33? Now let's first calculate the probability that the proportion is less than 0.33, because we know that we can do that easily by translating the 0.33 into a z-score, which is here, then translating that into a cumulative area. So this area right here is the probability that the score is less than 0.33. But we are interested in the probability that is greater than 0.33. So it means the blue area is what we're interested in. Now, what we know statistically, this area below and this area above, the probabilities together must be 1. So area shaded in blue plus area shaded in orange must be equal to 1. So therefore, the probability of being greater than 33 is just going to be equal to 1 minus the probability that it was less than 0.33. So that's what we found here. So it does require a little bit of manipulation. If you remember the basic principles that we used throughout this, was the first formula what was to find the standard deviation. Then from that, for each proportion, we can find a z-score, and having found a z-score, the norm this function now tells you what is the probability of having a proportion less than that corresponding z-score, which is the norms this, and one little reminder here. Once the function, there are several functions here that you can use in this chapter. Once it has an S in it, it is expecting z-scores. That's one little tip that you can keep in the back of your minds. So the one we need to use to reduce z-scores to cumulative areas is norms this, and then that gives you the area, which is also the probability that the score is less than that particular proportion. Alright, and obviously the parts where you want to find it being greater, you have to subtract the value below from 1 to get the area of what's left above on the right tail, so to speak. And if you wanted to find the area between two values, you find the area below the first, the area below the second, and then you subtract both. So take a look at it and slowly go through this video if you need to watch it again. I'm also going to give you this Excel document so that you can have it to look at the details. Alright, and again, if you have any questions, feel free to reach out to us. Alright, thank you for watching.